Something from nothing? Imagine opening your eyes to the entire universe, stars, galaxies, black holes, time itself, and realizing it may have all come from nothing. Not empty space, not a quiet void, but true, absolute nothingness. No atoms, no light, no laws of physics. Nothing. And yet, here we are. How is that even possible? How could something as vast, complex, and structured as the universe emerge from literally nothing at all? This question lies at the edge of science and philosophy. It has fascinated thinkers for thousands of years, and now, for the first time in human history, we may be getting close to an answer. Not a mystical one, but one grounded in the laws of quantum physics, cosmology, and the geometry of spacetime itself. This is the story of the universe's ultimate magic trick, existence from nothing. Defining nothing. Before we explore how the universe could emerge from nothing, we must ask a seemingly simple question. What is nothing? In everyday life, we treat nothing as the absence of stuff. An empty room, a blank page, or a vacuum, these all feel like nothing. But to physicists, even a perfect vacuum isn't truly empty. It's filled with quantum fields, zero-point energy, and virtual particles constantly flickering in and out of existence. True nothingness, if it even exists, would mean no space, no time, no energy, no laws, no quantum fields. But here's the twist. The laws of physics, particularly quantum mechanics, may actually require something to emerge even from nothing. In fact, they might make it inevitable. Quantum fluctuations and virtual particles. At the heart of quantum physics lies a strange and beautiful concept. The vacuum isn't empty. Even in its lowest energy state, space is teeming with uncertainty. Particles and antiparticles spontaneously appear, interact, and vanish in incredibly short timescales. These are known as virtual particles. This phenomenon is not science fiction. It has real, measurable effects. The Casimir effect. Two uncharged metal plates, placed close together in a vacuum, attract each other due to pressure from virtual particles. Hawking radiation. Black holes slowly evaporate because virtual particles at the event horizon become real. One falls in, one escapes. So if particles can emerge temporarily from quantum nothing, could an entire universe emerge from a deeper kind of quantum fluctuation? Many physicists think so. And that brings us to the realm of cosmology and the birth of everything we know. Inflation from nothing. The early universe underwent a rapid, exponential expansion called inflation. Within a fraction of a second, space itself grew from subatomic size to cosmic proportions. But where did this inflation come from? Some models suggest that a quantum fluctuation in a primordial field, like the hypothetical inflaton field, could trigger inflation. If the energy conditions were just right, that fluctuation could have led to the explosive expansion of a pocket of space, our universe. Importantly, this process does not require pre-existing space or time. Inflation could, in principle, begin from a quantum fluctuation within a state that is, by all practical purposes, nothing. In this view, the universe is a quantum event, and like all quantum events, it doesn't require a classical cause. Quantum gravity and the birth of spacetime. General relativity breaks down at the singularity, the theoretical point of infinite density at the start of the Big Bang. To go further back, we need a theory of quantum gravity, a fusion of general relativity and quantum mechanics. One such attempt is loop quantum gravity, LQG. In this theory, space and time are not continuous, but made of tiny discrete units, or loops. These loops fluctuate and can transition from a non-spatial, non-temporal state into full-blown spacetime. Another approach is string theory, where the fundamental units of reality are vibrating strings of energy, possibly existing in higher dimensions. In certain models, universes can tunnel into existence from a quantum vacuum. These ideas all point to one thing. Spacetime itself, the fabric of the universe, may not be fundamental. It may emerge from something deeper, or from nothing at all. Vacuum states and the multiverse. Modern physics suggests that what we call nothing might actually be a false vacuum, a temporary metastable state with higher energy than the true vacuum. Quantum tunneling from a false vacuum to a true vacuum could trigger the birth of a universe like a bubble forming in boiling water. This is a key part of eternal inflation theory, which leads to a multiverse, an endless number of bubble universes, each with different physical laws. In this scenario, universes are not special. They pop in and out of existence like quantum bubbles. Our universe may be just one of many, and its emergence from nothing may be the rule, not the exception. Nothingness in different theories. Let's revisit the idea of nothing under several different theories. Classical nothing, the absence of matter in empty space. Quantum nothing, the absence of particles, but still fields and laws. Metaphysical nothing, the absence of everything, no space, time, laws, or logic. Most scientific models operate with quantum nothing, the absence of particles, but not of structure. The true metaphysical nothing may be philosophically meaningful, but science requires a framework, and that framework still contains potential. Philosophical reflections. Philosophers have asked for centuries, why is there something rather than nothing? Some argue that nothingness is less stable than something, and so, perhaps existence is inevitable. Others suggest that existence doesn't need a cause, it simply is. Still others invoke logic itself, suggesting that if existence is possible, it must occur. Religious or metaphysical explanations invoke a creator or purpose, but the scientific view tries to describe how the universe could arise from nothing without needing external purpose. The mystery remains profound, but science gives us tools to explore it meaningfully. Evidence and limits. Is there evidence the universe came from nothing? Not directly, but observations of the CMB, the distribution of galaxies, and the success of inflationary models support the idea of a quantum origin. We also observe that the total energy of the universe may be zero positive matter energy and negative gravitational energy canceling out. Some theories even propose that the laws of physics are self-generating, arising naturally from mathematical logic or symmetry principles. Could it happen again? If a universe can emerge from nothing once, could it happen again? In some multiverse models, it happens endlessly. Quantum fluctuations in a timeless background can spark countless universes. We may even be living in one bubble among infinite others. The concept of cyclical cosmology also suggests that the universe undergoes infinite cycles of birth, death, and rebirth, though not necessarily from nothing, but from a previous phase. Whether the process is repeatable or not, it suggests that existence is far more dynamic than we once imagined. The meaning of nothing. So what does it mean to say the universe came from nothing? It means that the universe with all its galaxies, time, energy, and consciousness may have no origin point in the way we traditionally think. No need for a creator, no edge of space, no before. It means that physics, math, and quantum mechanics may be all we need to explain the greatest mystery of all, why there is something rather than nothing. And perhaps most importantly, it means we as conscious beings capable of asking these questions are part of the mystery. Our ability to think, reflect, and seek truth is not separate from the cosmos. It is the cosmos awakening to itself. If you enjoyed this exploration, don't forget to like, subscribe, and share this journey with other cosmic thinkers. The universe may have come from nothing, but our curiosity makes it truly alive.